Oh no, I just broke my guitar. It's okay, I won't fret. So let's talk about solving practical problems. Typically, in context, you're given some information. It involves raw scores, maybe z-scores, maybe a table, a diagram, and you can use things like in a calculator free, you could use the 68, 95, 99.7 rule, but you're relying on the z-scores being only 1, 2, or 3, or -1, -2, -3. You can use the actual probability distribution function for normal distributions. That's what's written there, even though it's tiny. Or you could use your calculator to solve. And as we talked about in the last video, there's our method for using a calculator. There's a bit more information, as well as in exercise 17C. There's also some in 17D, another example, so it's worth having a look at. Let's have a look at some practical examples, and it brings about a couple of things that we should talk about. Example 8 is from AQA, which is an English exam board. It's their D1 Decision Maths, and it's from June 2013. The weight, X grams of the contents of a tin of baked beans, can be modelled by a normal random variable with a mean of 421 and a standard deviation of 2.5. So again, I have copied this, and I can see that the mean is 421, and then the standard deviation is 2.5. So there's 423.5, here's 426, up there is 3 standard deviations, which is 428.5, so on and so forth. Find the probability that x equals, so this is A, part 1, the probability that x equals 421. And this is a really great opportunity for us to talk about some assumptions we might have to make with these discrete probability questions. Because the probability equals exactly 421, that's a infinitely small slither, is actually basically 0. And so we actually say, theoretically, it's 0. The chance of you finding something that equals exactly 421 is 0. But you might say, well, I measured it and I wrote down 421, and that would be the correct answer. Obviously, there's going to be some data, and 421 is actually quite likely to pop up in that data. That's because we've done some rounding. So we have to make an assumption now on our rounding. If we make the assumption that we've rounded to the nearest whole number of grams, which I think we will make, it's probably pretty likely, well, that means that 421 is actually between 420.5 and 421.5. So we're actually looking for the probability that x is greater than or equal to 420.5 less than 421.5. And remember that this greater than or equal to less than, these two signs, it doesn't really matter which one you use because x equaling exactly 421 is essentially 0. But we can do this calculation now, and we can do it on our calculator. So let's jump in and do that. That's not the right one. There's my calculator. So I'm going to use my normal cumulative distribution. I'm doing 420.5 as my lower bound. My upper bound is 421.5. My standard deviation is 2.5. My mean is 421. Close brackets, execute, and the probability is 0.159 or 1585, we'll say. So that's equal to 0.1585. That's A part 1. Now it actually gets a bit easier from here because we just want to find the probability that x is less than 425. And so I can do that on here. NCD, the probability it's less than 425, am I right? Yep, 425. So my lower bound, I'm going to say, oh, excuse me, I'll just put 0 as my lower bound because that's less than, and that's as low as it can go. 425 is my upper bound, and this has the same mean as standard deviation, 2.5 and 421, and close that bracket, and I get 0.9452, and that makes sense again because we're talking about 425, which is about here. So that's equal to 0.9452. And then the third one is the probability that x is between 418 and 424. And so we can just put that straight into our calculator as well. So I'll go back to my calculator and I'll just do the same thing. 418, 424. This is centered. This is one standard deviation above and below, so we don't really need to do this because you might already know the answer. 421. It should come out about 68 point something percent. Oh no, it's not one standard deviation above and below. My apologies. Standard deviation is not 3, it's 2.5. So it's a little bit more than that. 0.7699. 0.7699. Question B asks us, determine a value such that the probability that x is less than x equals 0.98. So I can do this using the same process as before. If I go back to my calculate, I can solve n, that's a numerical solve, and then I can go into stats, distribution, normal, and I can do an NCD. I want x, so this is x is less than little x, so we'll call it little x, and I'm going to use a less than, so my lower bound will be 0 again, and the probability is 0.98, and so I've got 0, comma, x, comma, 2.5, comma, 421, my standard deviation of mean, and I want this to be equal to 0.98, 98% chance, and I want to solve this for x, and then I close the brackets, and it tells me that 426.134 will do. So x has to equal 426.134. 98% of the data should be below 426.134. And then C, which is a bit trickier again, the weight, y grams of the contents of a tin of ravioli. Now, I'll have a tin of baked beans, but I'm not too sure about this tin of ravioli stuff. It can be modelled by a normal random variable with a mean of mu and a standard deviation of 3.0. Find the value of mu such that this, so this is, again, this situation, y is less than 410 equals 0.01. I'm going to use this time my solve n on my normal CD, and this time my lower bound will be 0 again, my upper bound will be 410. Now that's quite low, keep in mind, but it's a different tin, so we don't know what the mean is. My mean will be, my standard deviation is 3, my mean will be x, I want this to equal 0.01, and I want to solve for x. So I'm going to put that into my calculator, and in fact I'm not going to, I'm going to be lazy. Instead of jumping around, I'm just going to reuse the one I did earlier, and I suggest that you consider doing this yourselves as you do the exam and as you practice. So I'm changing this now to be standard deviation of 3, I'm changing this 421 to be my x, that's what I'm trying to find. I want this to be equal to 0.01, and I want to solve for x, execute, exit, and I get a couple of possible answers because you've got that reflection case, but in this case I can see the obvious answer is 416.97. So I'll just go up, see if I can get a bit more detail on that. 979, so I'll just call it 98, 416.98. So therefore, mu must equal 416.98 for that to work. And if I do my little diagram again, you can see how that works. So 416.98. So that means 413.98 is there, which means that 410.98 is there, and 410 is there. A bit over 2 standard deviations below the mean, and this needed to be 1% of the data. That makes sense. All the best.